Let's take an example of HF. We know HF is coming close to form a bond, correct? So two atoms have combined to form HF. Among HF, we know what? In our periodic table, let's just quickly do this and then we'll go back to that. Hydrogen is present here, correct? And we know these elements have tendency to lose electron. Hydrogen is a non-metal, but among below hydrogen, all the other elements, if you see, they can lose electron. Even hydrogen is electropositive, correct? Then fluorine, which is on the left hand side, have a tendency to gain electron, rather pull electron. So if you have hydrogen which have a tendency to be electropositive and fluorine have a tendency to be electronegative, if you are going to combine these two, what will happen? There is a covalent bond between HF. We know one electron of hydrogen and one electron of fluorine is getting shared. Which type of sharing it is? Mutual. What do you mean by the word mutual? Mutual means one electron H is giving, another electron fluorine is giving. Both are contributing equally and sharing the electrons. Correct? So they have shown it here. You can check this. Now, when this mutual sharing is there, correct, but how can it be a mutual sharing? Why, it can be because H is giving 1 and fluorine is giving 1 because they both want to have stability. So H says my atomic number is 1. If I share and if I have tendency for sharing one more from fluorine, my duplet will be complete. Same thing fluorine says. I have got how many electrons in my outermost shell? 7. So if I share 1 with hydrogen, my octet will be completed. Agree? But in reality, what happens? They do mutual sharing, but hydrogen says I am electropositive. And if I am electropositive, I have a tendency to push electron. Fluorine says I am electronegative. So I have a tendency to pull electron towards me. So this shared pair of electron will slightly drifted towards fluorine. Okay? And then what happens? I told you. Okay, fluorine is most electronegative element in our periodic table. So what will happen now? Fluorine is going to pull electron. And when the fluorine is having electron in its vicinity, in its area, it will get partial negative. This is the symbol. And hydrogen will get partial positive charge. And when you have these partial negative and partial positive, we call them development of charge. And if there is a charge in a molecule, such molecules are called polar molecules. I hope everyone is clear with it. Let's check this. Two hydrogen atoms. Both are equally giving 1 electron. Here also it's a covalent bond. But can any one of them will pull? No. Can any one of them will push? No. They will equally keep it at the center. So such molecules have no charge. Means such molecule will be non-polar. Are you all getting it? Such molecule will be non-polar. Okay? So we say HF is polar and the bond between them is polar covalent bond. Clear? Okay. From where this word I told you, it has come from the word North Pole and South Pole, indicating charges. Is that okay? So, when there are two charges, two poles, we have a word dipole. Now these charges, opposite poles, we know negative and positive always attract. So let's see what is happening here. The H positive and fluoride which is negative, they will be arranging themselves in such a way that negative is facing to the positive of another molecule, and this will create some type of attraction, and such attraction will be called dipole-dipole interaction, which is an attractive force. Why it's dipole? Because there is positive negative in one molecule and also positive negative in another molecule. Is that okay? So dipole-dipole interaction happens in polar molecules. What are polar molecules? The one where both the bonded atoms have electronegativity difference. What it means? One of them will be electropositive and the other one will be electronegative. Any other example which you can discuss here? Yes, you can say HCl. You can also talk about water. You can talk about HI. Is that okay? Now, so we say dipole-dipole is electrostatic force of attraction. What is electrostatic force of attraction means? Attraction between positive and negative charge. Okay? But this attraction which is happening is not within the molecule, it's between the neighboring molecules, and such molecules will have the charges, that is poles, and these poles are permanent. So we say they have dipole moment. Now what is dipole moment? Dipole moment arises when there is negative, that is partial negative and partial positive charge. We will be studying dipole moment later, but right now let's concentrate on this much only. Am I clear? What is dipole-dipole interaction? It's a force of attraction, especially the electrostatic force of attraction between two molecules having negative, partial negative and partial positive, that is poles. Since there are two poles in both the molecules, we call them dipole-dipole interaction. Now, what factors can affect dipole-dipole? Let us think. I'm sure now everyone must be having something in their mind regarding this. What is the must criteria? There has to be two different atoms. These atoms should have difference in electronegativity because there is electrostatic force of attraction. So, how much is the force of attraction? What exactly? Is it a strong force or is it a weak force? So let's see. Dipole moment, I told you we'll be doing this, is introduced by a term mu. Okay? So, dipole moment, how much is the force? It's calculated with this. If the value of dipole moment will be high, molecule will be having more dipole-dipole interaction. But how do we calculate that? There is a formula to calculate. Mu is equal to Q is charge, into multiply the distance between the two bonded atom. Okay, so mu is equal to Q into charge. Mu is equal to charge into distance, where charge is in coulombs, correct? And distance will always be in centimeter because they are very, very close, or maybe nanometer, or maybe Armstrong, or maybe picometer. Okay, so the distance will be between the negative and the positive charge. So basically it is bond length, and the unit for dipole moment is unit. Actually the unit will be charge into distance, that is coulomb meter or coulomb centimeter, but it is called d by. I repeat, how much is the polarity? How much will be the force of attraction between the two molecules depends on these charges, and these will ultimately be calculated by formula mu, which is charge into distance, and the unit of dipole moment is d by, that is capital D, which is also coulomb into distance. Okay, next. Now, what are the factors we said? What is this? Dipole moment. So they are saying dipole moment increases and it is proportional to force of attraction. What you conclude? More the dipole moment, which is given by mu, more will be force of attraction. Clear? Next. We know dipole moment is proportional to what? 0? Well, when there is no force of attraction, means there will not be polarity, means there will not be any development of charge between the two atoms. For example, H2, Cl2, will they have any charge? No. Will they have any force of attraction between them? No. So their dipole moment will be 0. Please understand, we say those molecules which have positive and negative charge will be polar and they will have dipole moment. So in short, you can learn it. Polarity in a molecule means they are having dipole moment. But those molecules which are non-polar means their dipole moment will be 0. Why will it be 0? Because these molecules do not contain any charge.